Hello everyone, in today's video we are going to solve a problem related to functions and their compositions. Okay, so this came in the Australian math competition. Okay, and this is a very famous exam there in Australia and probably the biggest math exam. Okay, so fine, here the function f1x is given. In some sense this is the first function, okay, which is x over x plus 1, and other functions like f2 f3 are there actually defined recursively. So once you know f1x, then f1 you know, and if you take n equal to 1 here, you will get f1 composition f1x, and that will give you f n is 1, so f1 plus 1, which is f2x, right? That way you can also calculate f3x once you know f2x. So put n equal to 2 here. Once you have calculated f2x here, so then f1 compose f2 will give you f3x, and so on. You can calculate all fn when n is a natural number, right? And the question asks what is the expression for f2024. Okay, that's all. So if you want to do the direct calculation, you have to calculate 2024 times the composition of functions, okay, which is not realistic. So therefore better we'll use some trick to find out what is f2024. This problem is easy but okay, interesting to solve. Fine. So first function f1x is given to be x over x plus 1, and the recursive definition is this: fn plus 1x is f1 of fnx, right? This is the composition of functions. Fine. So what is f2x if we try to calculate, just to explore things here? So f2x, if we want to calculate, then f2x is by definition here. So f2x means n we must put to be 1. So n equal to 1, then f1 plus 1 is f2, right? So f2x is then by this definition f1 of f1x, right? So that is what we have written here, f1 of f1x. Now first f1 is as it is, okay, f1, and what is f1x? That is given to you already. So f1x is x over x plus 1. So we have written that, okay, because f1x is given. Now this is f1 of something, right? Let's call it capital X, okay? So f1 of some quantity, we have known here that f1 of some quantity is that quantity over that quantity plus 1, right? So then what is f1 of this big quantity? Okay, we can write it simply: the same quantity which is here over that same quantity plus 1. So this is what it turns out, okay? This is what it turns out to be. So x over x plus 1 here, and then x over x plus 1 here plus 1, okay? So this is now, the whole thing is now acting as x, okay, because that is the argument of this function here. So now if you simplify x over x plus 1 in the numerator, and the denominator you get x plus 1 here, so 2x plus 1 over x plus 1, right? 2x plus 1 over x plus 1, and x plus 1 you can remove. So what we are left with is just x over 2x plus 1. That is how you can calculate f2x. Now once you have f2x here, so you can plug it in here, the whole f2x, and f1 of f2x will give you f of 2 plus 1, which is f3x, right? Let us calculate what is f3x. So this is f1x, this is fn plus 1, this is the definition. So f3x is what? By definition, by this definition, f1 of f2x, f1 of f2x here. So then what was f2x? f2x was x over 2x plus 1. So f1 of x over 2x plus 1, this f1 as it is. So again, f1x is x over x plus 1. So f1 of some quantity is that quantity over that quantity plus 1, okay? Again, if we simplify, what we get is x over 2x plus 1 and 3x plus 1 by 2x plus 1. Again, 2x plus 1, 2x plus 1 can be removed. So what we are left with is this x over 3x plus 1. So what we have achieved so far, the f1x which was given to us is this x over x plus 1, and then f2x is x over 2x plus 1. This is what we calculated, and then f3x is x over 3x plus 1. So can we see some pattern? Okay, is it like continuing in this fashion? We can get fnx equal to x over nx plus 1 for all n. Okay, that is what I mean, that is something which we do not know actually, okay? But one can prove that, at least one can guess that for f1 is there, it is 1, for f2x it is x over 2x plus 1, for f3x it is x over 3x plus 1. So one can make this guess, but you need a proof, right? And in such cases, when you have to prove something for all natural numbers n, the one most powerful thing is principle of mathematical induction. Okay, so that is what we will try to prove. Okay, so what is our assumption, or what is our statement which we want to prove is the following. So fnx is x over nx plus 1 for all n belong to n. So for all natural numbers, that is what our claim is. Okay, that is what our assumption is. Okay, so we want to actually prove, we basically assume that this might be true. Okay, so then we want to prove this by principle of mathematical induction. What is the first thing? This base case for n equal to 1, this is true, right? Because if 1x is x over 1 times x plus 1, which is true. And similarly, we have also seen that if 2x is x over 2x plus 1, and if 3x is x over 3x plus, so for n equal to 1, 2, 3, for all these values, it is true that fnx is x over nx plus 1. So now we want to make the hypothesis that suppose for n equal to some number it is true. Okay, for n equal to some randomly chosen number, let's say m, this is suppose true. Okay, then if we show that for m plus 1 it is also true, then we can actually use the induction, right? Well, so for n equal to m, if it is true, then what we have, that fmx is x over mx plus 1, right? And then if we try to calculate if m plus 1x, what it is, so by definition, if m plus 1x is f1 fmx, and we know what is fmx, right? Because f1 of x over mx plus 1, we have seen what is fmx, right? That is what we have assumed. So with this assumption, we can see here that if m plus 1x is x over mx plus 1, x over mx plus 1 plus 1, okay, that is the definition of f1. And then after calculation you get this, and then what you get is this x over m plus 1x plus 1. So it turns out to be true for n equal to m plus 1 also, given that it is true for any particular value m. Okay, and we are actually done with the proof. Why? Because for any m, if it is true, our calculation shows that m for m plus 1, so basically the next number, for the next number it must be true, right? Now for if 1 is true, right, for n equal to 1 it is true, for n equal to 2 it is true, for n equal to 3 it is true. And we have seen here that for if it is m, for m if it is true, then for m plus 1 if it is true. So for 3 it is true, therefore it must be true for n equal to 4, and then so on, n equal to 5, and so on. Okay, so therefore by principle of mathematical induction, we can conclude that fnx is x over nx plus 1 for all natural numbers n. Now once this expression is valid for all natural numbers n, what is f2024x? That is obvious, right? Just put n equal to 2024, and this is the final answer. Okay, yeah, that's all in this video. If you like the content, do press the like button and subscribe our channel to motivate us. I sincerely thank you for watching this video.